Okay, so now we're still doing the basics of geometry, and it's a little bit more advanced basics. The reason is these are still basics, but you need to know them before we continue on with the different shapes, sizes, and you know, whatever we want to do. Because when we start getting into these types of figures, we can even draw a star, or even a can, even a sphere. That's well. When we start getting into these, if you don't know your basics, even when we're starting into coordinate geometry, right, where we might have to draw these in space, we start getting into all these, and you don't know these basics, you're going to struggle. And so this advanced basic, what we're talking about is, and you know, this is kind of humorous, A advanced, and also A for angles. So there's so many concepts, fundamental really, and if you don't know them, you're going to be struggling. So, you know, let's get into the different characteristics and the classifications. All good, all good stuff. So, what's one of the things what we're going to talk about? So, we're going to talk about types of angles, and there are many types. You know, for instance, right, acute, and obtuse. Right? Terms you don't know, but you'll know very soon. Rotation of the angle. You know, pairs of angles. And what do we mean by that? Well, when we get into complementary and supplementary, you'll know what we mean. But for a preview, you know, you got a pair of pairs of angles here. And also, what happens when, you know, we have angles created when a transversal cuts to parallel lines. And so if you're familiar with the concept of Z's, C's, and trees, you know, all of these things I'm telling you will make so much more sense. But essentially, you know, this is the tree. What happens when, you know, we have the line, right? Then we have a cut here, or a cut here, or a cut here, right? What do we do with that? So we're going to get into all of these. And this may take more than one video. So let's see. So as a review, an angle is formed when two rays, which now we're going to term as the R of the angle, meet at a common endpoint. So let this not confuse you. You already know this dot right here is the vertex, and you know that, you know, here and here is ray, we'll call ray 1, ray 2, too. But now what we've said was, well, let's split the ray into its parts. So, or sorry, the angle into its parts. So we're not just going to look at the entire ray. We're going to look at the vertex and then just the arm of the ray. The arm of the ray. What is it? Well, it's everything but the vertex. Usually, when you're taking geometry, you'll have to know this, but when you advance, no, I've rarely seen anyone actually use the term arm. So it's not that big of a deal if you don't know. But because this is geometry, because you'll be taking it in your course and stuff, it's better off. It's better that you know it. But when I've seen standardized tests before, I've never seen anybody use it. It's usually, you know, you have a geometric shape, you know, find the angle, find the arm, find the distance between points, which we'll get into. But you know, knowing the fact that split your arm, I mean, it's, you know, it's fine. Okay, so, and remember, this is the angle. Now, I've usually just drawn the angle like this, but I can also draw it like this. Very, very slim, or, you know, to the point where they're touching so close to each other you can't really see it. Or I could just draw it wide like this, right? Like, it's so, you know, the easiest thing to do is to imagine a clock. A clock, and then just see how, you know, every time it changes, right? What's happening to the angle with the two rays, right? Right? The angles are always changing. They're getting larger and smaller. So knowing that and knowing that, you know, you can see how the angles play out in your everyday life with a clock. I think a clock's a very good example. There are a couple of different types of angles. This will define. So types of angles. So we have one, the acute angle. We have the right angle. We have the three obtuse angle. We have a 4 straight angle. We have the reflex angle. We have a 6 full rotational angle. Can't write today. Rotation angle. And then we also have 5 to 6 to 7, the 0 angle. This might seem like a lot, but it's really not. So we'll just jump right straight into these. Okay. First one, acute angle. And now this is a new concept for most of you, so it's going to require memorization. It's going to be hard at first, but it'll become very intuitive once you start practicing and doing a lot of problems with these. So what's an acute angle? So did I misspell angle? Oh no, I spelled it right. So an acute angle is less than 90 degrees, which is why it's called an acute angle. Acute meaning it's sharp, right? Like a sharp angle, right? Okay, next we have, and you know, you'll see it drawn like this. I'll get into how to distinguish between the acute, right, and obtuse very soon. And then we have the right angle. Exactly 90 degrees. And anytime you'll know an angle is right angle, they don't have to tell it to you, is when you see basically the angle denoted in a box form. Remember when I was drawing this angle, it was a semicircle, but this is a box form, so this is 90. And then so next, I'll fit it right here, obtuse. So this is greater than 90 degrees. Then 90 degrees. So all these first three angles are, they're in lockstep. They're defined based on the right angle. So as long as you know the right angle is exactly 90 degrees, then the other two will follow suit. The acute will be less than 90, and the obtuse will be greater than 90. And so, majority of the time, you'll be told that, this is 89 degrees, right? Or this is 150 degrees. They're not just going to draw a symbol like this, right as white, and expect you to know that this is an obtuse angle. Because if you've had a very good geometry teacher, they can easily trick you and draw something like this, right? And unless you read carefully, you might think that, this looks like a 90-degree angle, but, this might be 90 degrees, which is wrong. Or you might think it's obtuse, which would be wrong. So, let the figure be drawn, and most of the time they'll tell you, hey, this is, a 50-degree angle, right? They have to tell you what the angle is. And so this is just to get you to get out of assumption making and just see what the figure is and go based off the figures, right? So for instance, when you're, using a map, right, and then you're trying to make, a correlation between how many miles each, inches, right? So you're not just going to go and just automatically look at it and assume that it's, 5 miles for the 1 inch. No, you're going to actually look at the legend and see. So, you have to look at these legends. You have to look at what they're telling you the angle is, right? They're not going to say it's acute, right, or obtuse, right? They're going to draw it in for you. And this box will say, okay, this is 90 degrees. This is right. That 100% of the time, nobody will trick you on that. That is 100% of the time. But in these other instances, right, when they draw it, they'll have to tell you, well, this is a 151-degree angle, or maybe this is a 30-degree angle, right? So don't just go based off the drawings when you're seeing the acute and the obtuse angle. What you need to pay attention to is it less than 90? If it's less than 90, it's acute. If it's greater than 150, it's obtuse. Right. This is if you have a really good geometry teacher. He'll tell you don't depend too much on he or she will tell you don't depend too much on drawing, which is something I learned as well. But just keep that in mind, that this is what you need to keep in mind, is not so much the image, although most of the time the images will be like this, but not so much the image. You need to know the actual degrees to classify. All right, so let's get into something else. What is a straight angle? Okay. So this is 180 degrees. And how we can do this is if you draw a little circle, right? You'll end up seeing people kind of split in half and then drop. But let's extend this out. So a lot of people get confused on, well, how do you know what this line is? Well, just draw another line, and then you'll know that the lines, 180 one side, 180 the other side, right? So this is really telling you what is the degrees of a semicircle, essentially. It is 180 degrees, so that is a straight line. So let's do semicircle. Okay, so then the other two concept we have is a reflex angle, which it's an angle whose measure is bigger than 180 degrees. Keep drawing a percentage today, but it's less than 360 degrees. Come on. So, for instance, if you so you're seeing now how your algebra, basic math skills are coming into play. So greater than 180, but less than 360. So it's in an interval. So basically what we're saying is it's between 180, not including 180, and less than 360. Right, this is kind of weird, but so we have 181, right? That's reflexive, or 191, right? That's reflexive. But think of it this way. When I get into, I'll go ahead to the full rotation angle, and then come back to this. This is 360 degrees, and so this is a circle, right? So remember, if you have a compass and protractor and then you try to measure the angles and go all around, that is 360 degrees. Right, so you can never have anything above 360 degrees with a rotation. So what we're trying to say is this. Let's just say, let me clear this out. Going back to the reflex angle. You can never have more than 360 degrees, okay? Now we're doing a reflex angle. Now let's just say, because this will always work out, and I'm going to just do a right angle triangle. I mean, not right angle triangle. I'm just going to do a right angle. This is 90 degrees. Okay, measure here to here. Now, from here to here is 90 degrees. But then what's the angle of this? Well, that's 90. Well, that's 360 minus 90, and that's 270. Right? So 270 is your reflex angle. Right? So what if this was 30? Right? If it's 30, then this would have been 330. So you're sort of seeing how this acute obtuse, right, how they're all just playing a role in this. Now I've given names for each of the characteristics of the angle, but most of the time when you start doing this, you'll only be sticking with these terms, and you'll be solving for these reflex angles, for the 360 degrees, the full angle rotation, but nobody really uses those terms. This is just an identification you'll know in geometry, but nobody really uses this. You'll be knowing the process without knowing the terms. But that is okay. So these are just to get you to understand how all these concepts are correlated with each other. And again, we have the zero angle too, which I'll do really fast for you. And this is essentially, if you can have 360 degrees being, you can also have a zero angle. So think about this, right? Think about your clock, really, right? You have a small arm and a big arm. So what happens when the clock, when you have the big arm here and the little arm here, right, overlapping, right? There is no angle, right? There is no angle. That's what they're saying. So they're saying when your two rays intersect one another, right? When arm 2 is on top of arm 1 on top of arm 2, we have 0 degrees. So I threw a lot of terms at you all right now, but I think this is time to go and digest this. This has been a pretty long lesson, so we can continue the the next part of this lesson. But I've given you a lot to work with, so let me know if you have any questions, and that's it.